we're asked to determine whether the above argument is valid, and to do it by drawing an Euler diagram. I always pronounced it Euler when I was in school, and I don't remember being corrected. I think it might be Euler, though. Anyway, so an Euler diagram looks like this. If you live in China, then you live in Asia. You draw circles to represent all the people that fit one of the categories. So the first statement here, if you live in China, then you live in Asia. This red circle is going to be all the people that live in Asia. I don't know why I pronounced it like that. And then we're told that if you live in China, you live in Asia. So that means all the people that live in China are inside the circle of Asia, because everyone that fits the description of China, being from China, they also must fit the description of being from Asia, according to that first statement. And then this next statement, Jamie lives in Asia. So Jamie could be in two different places, right? Jamie could be in Asia but not in China. Jamie could be in China. So is the above argument valid? Since we just looked at it, we saw that there was two different places here. We can't reach the conclusion that Jamie necessarily lives in China, because the Euler diagram shows us there's an option that fits this statement but does not reach this conclusion. So we'd say that this is invalid. The following is an invalid syllogistic argument. All rational numbers are real numbers. All irrational numbers are real numbers. These are both pretty broad, right? This covers all rational numbers. This covers all irrational numbers. Usually a syllogistic argument has a major statement and then a minor statement that's related to the major statement. So we're supposed to choose a Euler. So I'll draw the Euler diagram that can help us choose Newton. All rational numbers are real numbers. So we'll call this our real numbers. And then rational numbers must be somewhere inside here. Because all rational numbers are real numbers. And then we have the statement that all irrational numbers are real numbers. So here's irrational numbers inside the circle of real numbers. So is the conclusion valid that all irrational numbers are rational numbers? It isn't, right? There might be some overlap, if we just willingly suspend our disbelief here and pretend that maybe rational and irrational, maybe something can be both rational and irrational. We know that it can't, but it's possible that the statements could overlap, but we can't make the conclusion that all irrational numbers, this orange circle, is inside the rational number circle. Okay, we haven't been given enough information to confirm that. So this would be a Euler diagram that accurately reflects that statement, why it's invalid, because they don't overlap. Let's see which one we got here. This one is getting closer. This is the one we want, okay, because it was demonstrating what we just drew before. Irrational numbers could be on the outside. Irrational numbers could be completely on the inside. Right, so out of those four, we're not choosing this one because all irrational numbers we're told are real numbers, so it should be inside this circle. This red circle should be inside the real number circle. This one's invalid for the same reason. This one is getting closer. Irrational numbers, according to the statements, they could be rational numbers because that would still be inside the circle of real numbers. This is the correct statement that we want because this has both of them involved.